In the previous video, we began to talk about how horizontal asymptotes arise in the graphs of rational expressions. And we talked about how in order to understand what's going on with horizontal asymptotes, you need to think about what's happening to the function as x becomes a very large positive number and as x becomes a very large negative number. In this video, we're going to develop some rules for figuring out the equation of the horizontal asymptote. Horizontal asymptotes, abbreviated here as HAs, occur when the degree of the denominator, in other words, the highest power in the denominator, is greater than or equal to the degree of the numerator. Horizontal asymptotes occur when the degree of the denominator is greater than or equal to the degree of the numerator. So that really can be broken down into two cases. One, or A, when the degree of the denominator is greater than the degree of the numerator, and B, when the degree of the denominator is equal to the degree of the numerator. Now, the example we saw in the last video was this one. H of x is equal to x plus 1 over x squared minus 1. And as we saw, as x got very large and very positive, or very large and very negative, the denominator got bigger much faster than the numerator, and so the function approached but never got to 0. So when the degree of the denominator is greater than the degree of the numerator, as it was in the example in the last video, the function is going to approach but never reach 0 in the y dimension. In other words, if the degree of the denominator is greater than the degree of the numerator, then the horizontal asymptote is the line with the equation y is equal to 0. And that's what we saw before. If the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote is the line y equals 0. Remember, horizontal lines have equations of the form y equals something because every point on a horizontal line shares the same y value. The second case is if the degree of the denominator is equal to the degree of the numerator. In this case, take a look at this function. Q of x is equal to x squared plus 1 over 2x squared minus 5. Here, we have x squared terms as the highest degree terms in both the numerator and the denominator. Now, if you consider what happens as x becomes very large and positive, well, certainly this plus 1 and this minus 5 are not going to have a very big impact in the overall value of the function. But the x squared term up here and the x squared or the 2x squared term down here are going to get bigger at similar rates, although this one will always be twice as big as this one. So here's that table of values illustrating that. As x goes towards positive infinity, in other words, as x gets larger and larger and positive, notice what's happening here, and you might want to pause the video to examine these. Both the numerator and the denominator are getting larger and larger. Notice how you get closer and closer to a value of 1 over 2 being the ratio of the numerator to the denominator. Similarly, as x goes towards negative infinity, as x becomes a very large negative number, notice that you have the same kind of thing happening. They're getting bigger at similar kinds of rates. It's not the same as the case where the degree in the denominator was bigger than the degree in the numerator. Now they're getting bigger at similar or the same rate, but the denominator is always twice as big as the numerator. So again, you're seeing that the ratio that the y value approaches is always getting closer and closer to a half as the numbers get larger and more negative. In other words, as x goes to positive infinity, the function is getting closer to a half, and same as it goes to negative infinity. So if the degree of the denominator is equal to the degree of the numerator, then the horizontal asymptote is the line y is equal to the ratio of the leading coefficients. The leading coefficient being the coefficient of the highest degree term. So if the degree of the denominator and numerator are equal, the horizontal asymptote is the ratio, is y is equal to the ratio of the leading coefficients. Here, 1 over 2. There's a 1 here and a 2 down here. Take a look at the graph. You see that the graph approaches the line y is equal to a half.